Welcome to MRL. In this learning session, we will learn the solutions of the examples of arithmetic progression, exercise 5.3 of a 10th CBSE textbook. Now let us begin. Now here this is example number 6 of the exercise 5.3. Now given the first term as 17, the T1 is 17, nth term is 350 and the common difference is 9, we have to find n and Sn. Now the first term is already given to us, that is a is equal to 17. Now nth term, that is Tn is equal to a plus n minus 1 into d is the formula here. Substituting the value of Tn 350, it is given. A is given 17 plus n minus 1, also d is given as 9, and therefore by simplification we get n is equal to 38. Now we have got n as 38 and we have to find now Sn. Sn is S38. So here, since I know the first term and the last term, I can use the formula Sn is equal to n upon 2 in the bracket a plus l, and n is 38 by 2, a is 17, l is 350, and therefore S38 is equal to 19 into 367, that is 6973. So that is what is the value of S38, or the sum of 38 terms of the given example. Now coming to the next example, we are given d is equal to 7, the 22nd term is 149, we have to find 22nd, the sum of the 22 terms. Now Sn is equal to n upon 2 in the bracket a plus n minus 1 into d, S22 is equal to 22 upon 2 in the bracket a plus 21 into 7. Now the thing is, we do not know the value of a here. So to find a, let us use the Tn formula, that is Tn is equal to a plus n minus 1 into d. Tn is that is T22 is equal to a plus n minus 1 is 21d, that is equal to, since we know T22, that is 149, is equal to a plus 21 into 7. So d is also known, 21 into 7, so is equal to a plus 147. So a is equal to 2. So I can put the value of a here as 2, therefore it becomes 149. So 22 upon 2 into 149 is equal to 11 into 149, and that is 1639. Therefore the sum of 22 terms is 1639. Remember that. Now coming to the next example, we are given the second term is 14 and the third term is 18. The second term is 14, the third term is 18. We have to find the sum of 51 terms. Now we know the formula for Sn. Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. And thing is, we do not know a and d both here. We do not know a and d. And also n, of course we know, that is 51. So S51 is equal to 51 upon 2 in the bracket 2a plus n minus 1 into d. Now let us find a and d first. To get a and d, that is two unknowns, I require two equations, and the one equation is T2 is equal to 14 and the other one is T3 is equal to 18. So let us go for it. Now T2 is equal to a plus d is equal to 14, that is equation number 1. T3 is equal to a plus 2d is equal to 18, that is equation number 2. Let us solve 1 and 2 to get both a and d. Now so a plus d is equal to 14, a plus 2d is equal to 18, subtracting we get d minus d is equal to minus 4, or d is equal to 4. Put the value of d in one of the equations, that means a plus d is equal to 14, a plus 4 is equal to 14, a is equal to 14 minus 4, a is equal to 10. So I have got the value of d as 4 and a as 10. Now I can substitute the values here. So 2 into 10 plus 51 minus 1 into 4. So by simplification we get 5610. So therefore S51, that is sum of 51 terms, is 5610. So very simple example, but you have to understand how to use the correct formulas and how to get the unknowns by solving two equations there. So now let us go to the next example. We are given the seventh term, the sum of 7 terms is 49 and sum of 17 terms is 289. There is an AP, the sum of 7 terms is 49, the sum of 17 terms is 289. Now we have to go to, so let us find Sn. Now to find Sn, we will solve this example in 4 parts. So now for finding Sn, I use the formula Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. And to find the Sn value, we do not know a and d. We have to find a and d first. To find a and d, these two unknowns, we require two equations, and therefore I will be using S7 is equal to 49 and S17 is equal to 289, these two equations. So we have the formula Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. S7 is equal to 7 by 2 in the bracket 2a plus 7 minus 1 into d, or 49 is equal to 7 by 2 in the bracket 2a plus 6d, 49 into 2 by 7 is equal to 2a plus 6d, or 14 is equal to 2a plus 6d, or 2a plus 6d is equal to 14, or a plus 3d is equal to 7. I have got the first equation from S7 is equal to 49. From the second equation, S17 is equal to 289. Again, let us go for finding out the second equation. Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d is the formula. S17 is equal to 17 by 2 in the bracket 2a plus 17 minus 1 into d, or 17 upon 2 in the bracket 2a plus 16d, or 289 into 2 by 17, taking this on the left LHS, is equal to 2a plus 16d, 34 is equal to 2a plus 16d, 17 is equal to a plus 8d, or a plus 8d is equal to 17. So we have got the second equation. Now solving these two equations, I will get the value of d here, that is solving a plus 3d is equal to 7 and a plus 8d is equal to 17. By subtracting, I get minus 5d is equal to minus 10, or d is equal to 10 by 5, or d is equal to 2. Now putting the value of d is equal to 2 in one of the equations, we get a is equal to 1. So now I have got a and d. Now I can substitute in the formula Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. By substituting the value of a, that is 1, that is 2 into 1 plus n minus 1, d is 2, n minus 1 into 2, n upon 2 in the bracket 2 plus n minus 1 into 2, or n upon 2 into 2 in the bracket 1 plus n minus 1, or in the bracket 1 plus n minus 1, minus 1 and plus 1 cancels. So we have got n into n is n square. So we have got the sum of the n terms is n square. So that is how we have solved this example in 4 steps. Because to find out Sn, we need the value of a and d. I have solved the two given equations to get the values of a and d. I have got the values of a as 1 and d as 2, and by substituting there we get Sn is equal to n square. And this is a very interesting and very important formula, and this Sn is equal to n square is a formula to find the sum of odd numbers, or if n odd numbers are to be added, then we can use the formula n square. Now coming to the next example, we are given here an is equal to 3 plus 4n to show that a1, a2 and so on to an form an ap. Now let us see how to solve this. an is equal to 3 plus 4n. Now a1 is equal to 3 plus 4 into 1, so therefore a1 is equal to 7. a2 is equal to 3 plus 4 into 2, 3 plus 8, therefore a2 is 11. a3 is equal to 3 plus 4 into 3, therefore it is 3 plus 12, that is 15. So we have 3 terms here, 7, 11 and 15. The difference is 11 minus 7 is 4, 15 minus 11 is 4. That means these are 100% the terms of an AP. Therefore a1, a2 and so on to n form an AP. So that is how we solve it. Now coming to the next example, given an is equal to 9 minus 5n, that is what is given. Now finding out a1, we get 9 minus 5 into 1, that is 9 minus 5, that is equal to 4. a2 is equal to minus 1 and a3 is equal to minus 6. Therefore the terms are 4, minus 1, minus 6 and so on. So we find that the d is constant here. Minus 1 minus 4 is minus 5, minus 6 minus of minus 1 becomes plus 1. So minus 6 plus 1 is minus 5. So please correct this, it is minus 5, and therefore we find that d is constant, that is minus 5, and therefore the term form an AP. Now let us go to the next example. We are given Sn is equal to 4n minus n square, and we have to find t1. We have to find t1 plus t2, that is the sum of the first two terms. We have to find the second term, we have to find the third term, we have to find the 10th term, and also we have to find the nth term. So let us see how to solve this. Now to find the first term, that is the t1, Sn is equal to 4n minus n square, that is what is given. So where n is there, put 1. S1 is equal to 4 into 1 minus 1 square, or 4 minus 1, or 3. Therefore the S1 is the sum of first term is first term itself, so t1 is equal to 3, or a is equal to 3. Now to find S2, S2 is equal to, where n is there, put 2, so it will be 4 into 2 minus 2 square, 8 minus 4 is equal to 4, so we have got S2 is equal to 4, but you know that S2 is sum of first two terms, therefore T1 plus T2 is S2, so T1 plus T2 is equal to 4, and that is what is T1 plus T2, and the answer is 4. Now coming to find T2 now. Now T1 plus T2 is equal to 4. We already know what is T1. T1 is 3 here. So put T1 is equal to 3 here. 3 plus T2 is equal to 4. T2 is equal to 4 minus 3, and T2 is equal to 1. So we got the value of T2. Now come to find T3. Before I go for finding T3, let us see what will be D. D is equal to T2 minus T1. We know that D is equal to T2 minus T1, and T2 is 1 and T1 is 3, and therefore we got the value of D here. Now it is very easy to find the other values. T3 is equal to T2 plus D, and D is minus 2, therefore T2 is 1 plus of minus 2 becomes 1 minus 2, and that is minus 1, therefore T3 is minus 1. Now if you have to find T10, T10 is equal to A plus 9D. A is known to us, it is 3 because the first term is 3, plus 9 into minus 2 because we have found out D here, minus 2. 3 minus 18 is equal to minus 15, therefore the 10th term is minus 15. Now to find the nth term, the Tn is equal to A plus n minus 1 into D, 3 plus n minus 1 into minus 2, 3 minus 2n plus 2, 5 minus 2n, therefore the nth term is 5 minus 2n. So we have found out so many values here, but remember how to solve them. It is a very easy example, but you have to understand the basics of solving, so it will be easy for you to solve them. Now coming to the next example, to find sum of the first 40 positive integers divisible by 6. Please understand, to find sum of first 40 positive integers divisible by 6. That means we have to find S40. Okay, now let us see what are the terms of the AP first. Now they are divisible by 6, so it is 6, 12, 18, 24, and but natural 40th term will be 6 into 40, that is 240, 6 4 to 24, 240. So these are the terms. Now we have to find S40. To find S40, since I know the first term and the last term, I will use the formula Sn is equal to n upon 2 in the bracket A plus L, or S40 is equal to 40 upon 2, because I have to find S40. 6, A is already known to us 6, L is known to 40, substituting we get 4920. So the sum of first 40 positive integers divisible by 6 is 4920. Remember that. Now to find the sum of the first 15 multiples of 8. The first 15 multiples of 8 will be 8, 16, 24, and the 15th multiple will be 120. Now we have to find S15. Yes, again here I know the first term and the last term, so I can use the formula Sn is equal to n upon 2 in the bracket A plus L. So S15 is equal to 15 upon 2, A is 8, and L is 120. Substituting, I get S15 as 960, and try to remember that and learn and practice it. Now coming to the next example, to find the sum of the odd numbers between 0 and 50. Okay, we have to find the sum of the odd numbers between 0 and 50. Now what we are given is 1, 3, 5, 7, 9 and so on up to 49 are the odd numbers. Now we have to find the sum of this. So now let us use the, here we do not know n, let us find n first. So Tn is equal to A plus n minus 1 into D, that is Tn is 49, and A is 1 plus n minus 1, that means n minus 1 into 2, 1 plus 2n minus 2, 2n minus 1, so 49 plus 1 is equal to 2n, 50 is equal to 2n, n is equal to 50 by 2, and therefore it is 25. So it is n minus 1 here, so remember that. Now we have got n is equal to 25. Sum of odd numbers is n square, so there are 25 terms, therefore 25 square becomes 625. Therefore the sum of the odd numbers between 0 and 50 is 625. So please understand here, I have found out n. Once I find n, the sum of odd numbers, you know, it is given by the formula n square. So since I know n is 25, if I square it, it will be 625, and that is the value of the sum of the odd numbers between 0 and 50. Now penalty for delay in construction. This is an example here. Now what he gives is that penalty for delay in construction. Now what is the penalty for delay in construction? We have to find that. Now the first day, the delay, if there is a delay for the first day, the amount paid is 200 rupees. Second day, if there is another day delay, then you have to pay 250, that means 50 rupees extra. So like that, the penalty for each additional day is rupees 50. Now we have to find the penalty paid for 30 days. So let us understand this. Now here, the initial value, the first term, or the initial value is 200, therefore the first term is 200, or A is 200. The common difference is 50, because 50 rupees is the increase every day, and number of days are 30, therefore n is equal to 30. Now we have to find out the sum or the penalty paid for 30 days, therefore we have to find S30. S30 is equal to 30 upon 2 in the bracket 2A, 200, and plus 29 into 50, because 30 minus 1 is 29, into D is 50. So simplifying this, we get 15 in the bracket 400 plus 1450, that is equal to 15 in the bracket 15 into 1850, or 27,750 rupees is the penalty to be paid for the delay of 30 days. Now coming to the next example, the amount is the total amount for the prize money is rupees 700, number of prizes are 7, difference in prize money is rupees 20. Now we have to find the value of each prizes. So let us understand this. The total amount is 700. That means the sum of all the prize money, all the 7 prize money is 700 rupees. Therefore Sn is 700. N is 7. So S7 is 700. And D is minus 20 because the prize money decreases by 20 rupees for every prize. So therefore we have S7 is equal to 7 upon 2 in the bracket 2a plus 7 minus 1 into minus 20. 700 equal to 7 by 2 in the bracket 2a plus 6 in the 6 into minus 20, or 7 upon 2 in the bracket 2a minus 120. 700 is equal to 7 in the bracket a minus 60. 7a minus 420. 7a is equal to 700 plus 420. We have 7a is equal to 1120, or a is equal to 1120 by 7. Therefore a is equal to 160. So that means the first prize money is rupees 160. The second prize money will be 20 rupees less, so 140. Again third prize is 120, 20 rupees less. Fourth prize will be 100, again 20 rupees less. So on, we have the seventh prize, the amount is 40 rupees. When we add all these the prize monies of the 7 prizes, we find the total amount is 700, and therefore the prize money for first, second, third, fourth, fifth and sixth and seventh rank is correct, and therefore the difference is rupees 20 between them. So the procedure is whatever the procedure is followed in calculation here is correct, and please learn that. Okay, remember that. Now coming to the next example, number of plants planted by each class is equal to the class. That is, let us understand this. Number of plants planted by each class is equal to the class. Means if the first class is there, they will plant only 1 tree. If there is if it is second class, then they will plant 2 trees. Third class 3 trees. Fourth class 4 trees. And therefore there are 12 classes. Therefore the first class is 1, second class 2 trees, third class 3 trees, and so on. The 12th class will plant 12 trees. In all, they will plant n in the bracket n plus 1 upon 2 trees. That means since we have got n is equal to 12 here, 12 in the bracket 12 plus 1 divided by 2, 6 into 13. So 78 trees are planted by all the 12 classes. But there are 3 sections of each class, and therefore the number of trees planted are 78 into 3, that is 234 trees. Now coming to the next example, a spiral is made of successive semicircles. Please understand this. A spiral is made of successive semicircles with alternate centers A and B. So there is center A here, there is center B here. With center A, semicircles of radii 0.5, 1.5, 2.5 are drawn, and with center B, semicircles of radii 1, 2, 3 are drawn, and in all there are 13 semicircles. Please understand, there are 13 consecutive semicircles, and we have to take pi as 22 upon 7, and we have to find the total length of the spiral. So let us understand this. The semicircles with center A are having radii. The semicircles with center A are the first semicircle, the third, the fifth, the seventh, the ninth, the 11th, and the 13th semicircle. And the semicircle with center B are the second semicircle, the fourth, the sixth, eighth, 10th, and 12th. So in all, we have 13 consecutive semicircles. Now to find the total length of the spiral, we have to take the semicircles with center A first and add them to the semicircles of center B. Now that means we have to find the lengths there. Now to find the semicircles with center A, the first semicircle is 0.5 pi, because you know that semicircle means it is pi r, so r is 0.5, so it will be 0.5 pi. Then the second semicircle is 1.5 pi, 2.5 pi, up to 7 terms, because with the center A. Now with center B, it will be pi, because the radius is 1 and the radius is 2 pi, so it is 2 into pi, 3 pi, 4 pi, up to 6 terms. Now what we will do is we will take the pi common in both the cases. So if I take the pi outside here, it will be 0.5, 1.5 plus 2.5 and so on up to 7 terms, and taking pi here, I have got 1 plus 2 plus 3 plus 4 up to 6 terms. Now let us go to find the sum of the 7 terms and the sum of the 6 terms. So I have used here, so 0.5 plus 1.5 up to 7 terms. A is 0.5, n is equal to 7, d is equal to 1. So I can find S7. S7 I have found out to 49 by 2. And similarly the sum of 1 plus 2 plus 3 up to 6 terms, n plus 1 upon 2, 6 into 7 upon 2, that is 21. You know that the sum of natural numbers formula is n plus 1 upon 2, that I have used directly here. Now I have got we have the value of the sum of the terms in the bracket here and also the second bracket. Substituting, we get 49 by 2 plus 21, pi is common, pi in the bracket 49 by 2 plus 21. Now simplifying this, we get 11 into 13 or 143 centimeters. Therefore the total spiral length is 143 centimeters. So slightly different type of example. Try to understand, learn it and practice it so that you understand the example clearly. Now coming to the next example, there are total number of logs given to us 200. There are 200 logs. Logs are stacked. The bottom row has got 20 logs stacked one above the other with one log less in each stack. The logs in stack are 20, 19, 18, 17 and so on. So we have to find out the number of rows of stacks and the number of logs in the topmost stack. Let us understand this. Now we have been given here the total number of logs are 200, that means Sn is 200. A is 20 because the initial the row of logs has 20 logs in it, therefore A is 20. 1 is less in every stack, therefore D is minus 1. And to find n and tn, we have to find out the number of rows and also the number of logs in the last stack. Now Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. That means Sn is 200, n upon 2 in the bracket 2 into 20 because A is 20 here, plus n minus 1 into minus 1. 400 is equal to n in the bracket 40 minus n plus 1, n in the bracket 41 minus n, and that is equal to 41 n minus n square minus 41 plus 400 is equal to 0. When we simplify this by middle term splitting method, we get two factors, n minus 25 and n minus 16 equal to 0, or we find that n is equal to 25 and n is equal to 16. Now we have got two values of n. Let us see which is the correct one in that. Now coming to tn, tn is equal to a plus n minus 1 into d. And we have A is 20, 20 plus n minus 1 into minus 1, 20 minus n plus 1, tn is equal to 21 minus n. If n is equal to 25, see n is equal to 25 here, so taking n is equal to 25, we get t25 is equal to 21 minus 25 is equal to minus 4. So the value has come as minus 4 here, which is not possible. Therefore remember, t25 is equal to minus 4 is not at all possible. So now let us take n as 16. When we take n is equal to 16, t16 is equal to 21 minus 16, that is equal to 5. So that means which is definitely possible, and therefore there are 16 rows. There are 16 rows, that means n is 16 rows, and there are 5 logs in the top row. Okay, so that is what is the answer for this particular example. Now let us go to the next example. This is slightly different example. Let us understand what is this. Now there is a bucket, and a person has to pick the potatoes placed here. 10 potatoes are placed. A person has to pick and put in the bucket. Now he starts from the bucket. The first potato is at 5 meters. He runs from the bucket to the first potato and runs back and puts it in the bucket. That means he has traveled 5 meters in the forward direction, 5 meters in the reverse direction, and the total distance is 10 meters. Okay, so the first potato he picks and drops and runs a distance of 10 meters. Now we have to find out the total distance the competitor runs to put all the 10 potatoes back into the what you call the bucket there. So the first potato is at 5 meters from the bucket, so the total distance is 2 into 5 meters. The second potato is 5 plus 3 meters and 2 times that, so it is 2 in the bracket 5 plus 3 meters. The competitor has to put all the potatoes in the bucket, running the distances until all the potatoes are put in the bucket. We have to find the total distance run by the competitor. Now the total distance will be 2 into 5 plus 2 in the bracket 5 plus 3 plus 2 in the bracket 5 plus 6, because the second potato will be at 6 meters, and so on up to 10 potatoes. That means here if you find that 2 is common, taking 2 outside, we have got 5 here, plus 5 plus 3 is 8, 5 plus 6 is 11 and 14 and so on up to 10 terms. Now adding these values 5 plus 8 and all that, if you add, we get 185. So it will be 2 into 185. So finding S10, I have done it here, that is n upon 2 in the bracket I have calculated here. So we can get the values as 185. So therefore we find 2 into 185 is 370 meters. Therefore the total distance run by the computator is 370 meters. So this is how we get the value, that means the distance, that is 370 meters. So that is how we solve the examples of arithmetic progression. Understand the basics, learn the basics, and apply the basics what you have learned to solve the examples. Okay, note down in a book as a reference for your future. Okay, thank you.